If your pivot table freezes, shows not responding, or just spins forever, the problem usually isn't the pivot table itself. It's the engine behind it, pivot cache, the workbook's data model, and a few settings that quietly multiply the work Excel has to do. The good news is, you can fix most cases without rebuilding everything. First, think of a pivot table refresh as a pipeline. Excel reads source data, builds or updates a cache, then calculates and draws results. If any step becomes huge or unstable, you feel it as a hang. In this guide, you'll learn a practical sequence, confirm what's actually slow, reduce cache bloat, stop accidental cache duplication, and keep the data model from doing unnecessary recalculation. You'll also learn when the fix is to change the source layout, and when it's a simple setting like disabling background refresh. The goal is simple: refreshes that finish and pivot tables that stay responsive. Next step. Let's separate freezing into a few common patterns, because each points to a different root cause. Pattern 1. Excel locks up exactly when you click refresh. That often means cache rebuild or a heavy calculated field. Pattern 2. It refreshes, but scrolling or expanding items becomes painfully slow. That's usually cache size, too many pivot items, or memory pressure. Pattern 3. It only freezes after you add a slicer, a relationship, or a measure. That points to the data model and DAX calculations. Pattern 4. It works on your machine, but not someone else's. That's often different Excel settings, add-ins, or 32-bit memory limits. Your job is to identify which pattern you're in before changing anything. Otherwise, you can spend an hour tweaking the wrong thing. As a baseline, note the dataset size, number of pivot tables, and whether you're using the data model. Those 3 details explain most performance surprises. Next step. Before you optimize, do 2 quick checks that prevent false diagnoses. First, confirm Excel isn't waiting on an external connection. If your pivot table is based on a query, a network file, or a database, a freeze can be a slow connection. Second, check if Excel is stuck in a calculation loop. If the workbook is set to automatic calculation and you have volatile formulas, like offset or indirect, Excel can recalc repeatedly during refresh. A simple test is to temporarily switch to manual calculation, refresh once, then calculate. That isolates refresh time from formula time. Also, close other heavy workbooks. Pivot refresh is memory hungry, and when Windows starts paging to disk, everything feels frozen. These checks don't solve the root cause, but they stop you from blaming the pivot table when the real issue is connectivity, recalculation, or memory pressure. Next step. Now let's talk about the pivot cache, because it's the most common reason a pivot table becomes sluggish. The pivot cache is a stored snapshot of your source data that Excel uses to compute the pivot table quickly. But quickly only works if the cache stays reasonable in size and doesn't multiply. The cache grows with every unique item in each field. If you have a field like comment, transaction ID, or a timestamp down to seconds, you can create millions of unique items. That makes the cache huge, and Excel can appear to hang while building it. Another hidden factor is pivot items that Excel remembers even after data changes. That can keep old items in memory and inflate the cache over time. So the first performance mindset is, pivot tables love clean, categorical fields. They struggle with high cardinality text and unique identifiers. Next step. A practical fix is to reduce high cardinality fields before they ever reach the pivot table. If you're grouping by date, don't feed the pivot a full timestamp if you only need day or month. Create a helper column that rounds or extracts the level you need, like month start or date only. If you have long text fields, keep them out of the pivot and use them only for lookups or drill through. If you need transaction ID, consider using it only in the detail view, not as a row label. Also, remove unused columns from the source range or query. Every extra column is another field Excel has to index and potentially store. This is one of the highest impact changes because it reduces work at the source, not after the cache is already bloated. You'll often see refresh time drop dramatically just by simplifying 2 or 3 fields. Next step. Next, stop accidental cache duplication. Many workbooks have multiple pivot tables that look similar, but each one quietly builds its own cache. That means the same dataset is stored multiple times, and refresh runs multiple rebuilds. The usual cause is creating pivot tables from slightly different ranges, or copying a pivot table in a way that breaks cache sharing. The best practice is to base all pivot tables on the same source table, or the same connection, so Excel can reuse one cache. If you already have many pivot tables, consider rebuilding them from one master pivot table copy that you know shares the cache. Cache sharing isn't just about speed. It also reduces file size and lowers the chance of memory-related freezes. One shared cache is easier for Excel to manage than 5 separate ones. Next step. There's also a setting that can make a workbook feel progressively slower. Excel can keep items deleted from the data source inside the pivot table. Over time, that creates a growing list of old categories that no longer exist, and it increases memory use and filter complexity. The fix is to change the retention behavior so the pivot doesn't keep those old items. After that, refresh the pivot table to rebuild the item list cleanly. This is especially important for dashboards that refresh daily or weekly, where categories come and go. If you've ever opened a filter and seen a huge list of values that shouldn't be there anymore, that's a clue. Cleaning retained items won't fix every freeze, but when it's the cause, the improvement is immediate and very noticeable. Next step. Let's move from cache size to refresh behavior. A surprisingly common spinning issue is background refresh. When Excel refreshes in the background, it can look like nothing is happening, or it can lock parts of the workbook while the connection is still running. For local data, this often adds confusion without benefits. Another issue is refreshing multiple pivots and queries at once. If you have a workbook that refreshes everything on open, you can create a startup freeze that feels like corruption. A better approach is controlled refresh. Refresh the data first, then refresh pivot tables, then calculate. If you use Power Query, load only what you need and avoid refreshing queries that aren't used by any pivot table. The key idea is sequencing. Excel is faster when you refresh in a predictable order instead of letting everything trigger everything else. Next step. If your pivot tables use the data model, performance depends heavily on relationships and calculations. The model is powerful, but it's not free. Poor relationships, like many-to-many without intention, can create expensive evaluation paths. Also, measures that iterate row by row can be slow on large tables. A simple rule is keep relationships clean and star-shaped when possible. That means one fact table with numeric data and smaller dimension tables for categories like customer, product, and date. Another rule is to prefer measures that aggregate columns directly, and be cautious with complex filters that force the engine to scan large tables repeatedly. If a freeze started right after adding a relationship or measure, that's your suspect. Temporarily remove the new piece and test refresh again. You're not guessing. You're isolating the change that increased model workload. Next step. Another big lever is data types and cardinality inside the model. If a column is stored as text when it should be a number or date, the model can't compress it efficiently. That increases memory and slows scans. High cardinality columns like GUIDs, invoice numbers, or exact timestamps also compress poorly. You don't need to delete them, but you should avoid using them in slicers, rows, or columns. If you need them for drill-through, keep them in the detail table, not in the main reporting layout. Also, be careful with calculated columns in the model. They are computed for every row and stored, which can bloat the model. Often a measure is better than a calculated column because measures calculate only when needed. The performance mindset here is store less, compress better, calculate on demand. Next step. Let's talk about the pivot table layout itself. Certain features make Excel do more work than you expect. Show items with no data can explode the number of displayed combinations. Multiple nested row fields with subtotals can also increase calculation and rendering time. And if you use distinct count, Excel often pushes work into the data model, which can be slower on large datasets. Another common slowdown is too many slicers connected to too many pivots. Each slicer change triggers updates across connections, and that can feel like a freeze. A practical approach is to simplify the layout, start with one pivot table, minimal fields, no subtotals, and confirm it's fast. Then add complexity one piece at a time. If performance drops after one feature, you've found the cost driver. Next step. Sometimes the freeze is actually Excel struggling to render, not calculate. Large pivot tables with thousands of visible rows, conditional formatting, and repeated styles can become a drawing problem. If you copy pivot tables into many sheets, each sheet adds more objects and formatting rules for Excel to manage. A clean strategy is to keep the pivot table itself lean and use a separate summary view for presentation. Also, consider turning off unnecessary formatting features, like auto-fitting columns during refresh, or heavy conditional formats applied to entire columns. If you need conditional formatting, scope it to the actual value area, not whole sheet ranges. Rendering issues are tricky because the cache might be fine, but Excel still feels stuck. The clue is when refresh completes, but interaction stays slow. That points to display complexity. Next step. If you want a reliable troubleshooting workflow, use a controlled test. Make a copy of the workbook and work in the copy. Then disable anything that can mask the real cause. Turn off add-ins you don't need, set calculation to manual, and refresh only one pivot table. Next, measure changes. Remove one suspect field, refresh, and note the time. Re-add it, then test the next suspect. This one change at a time approach feels slow, but it's the fastest way to avoid random tweaks. If you discover one field causes a massive slowdown, you can redesign just that part, like replacing a timestamp with a date bucket or moving a text field out of the pivot. The outcome you want is a short list of specific culprits, not a vague sense that Excel is broken. Next step. Let's wrap it up with a simple checklist you can reuse. If a pivot table spins, first decide if it's connection, calculation, cache, model, or rendering. Then reduce unique items, remove unused columns, and make sure pivot tables share a cache. Clear retained items so filters don't grow forever. Control refresh order so Excel isn't refreshing everything at once. If you use the data model, keep relationships clean, fix data types, and avoid high cardinality fields in slicers and layouts. And finally, keep the pivot table presentation light so Excel isn't choking on formatting. If you apply these in order, you'll fix most not responding cases without rebuilding your report from scratch. If you want more Excel performance deep dives, subscribe once, and for a quick check-in, comment with your main setup. A. Classic pivot cache, or B. Data model. I'm always testing new ways to work smarter. Subscribe to see what workflow I'm breaking down next.